Hello everybody. In the previous video we have discussed about LR parsing and we have seen the different types, and we have also discussed about something called items, LR0 items. So we saw how LR0 items are constructed. Now for construction of the parsing table of an LR parser, that is, we are now going to talk about LR0 and SLR1, simple LR. Okay, so we said that both of these use the same LR0 items. Okay, so we'll see how the table is constructed, but for this we need two procedures to be used. One is called closure and the other is called Goto. So let's see what these are. So the definition of closure is, suppose I is a set of items. Okay, so I is a set of canonical items that we talked about. Then the closure of this set of items is, two rules are there. The first one is very trivial. So if I is a set of items, then every item of I is also in closure of I. So suppose my item set is S dash is this. This is my item. Then closure of I0 will contain all items of I0. Closure of items will contain this also. It will have itself. So this is like the base case. Then the second point, which is most important, is that if you have in closure of I, if you have an item like this, A derives alpha dot B beta, where alpha is a string of grammar symbols, beta is also another string of grammar symbols, and B here is a non-terminal. Okay, so it's a variable. So if this is in closure of I, okay, and there is a production with B derives gamma, something of this type. Okay, in that case, we will include in the closure of I the item B derives dot gamma. So again, let's see an example. So I have S dash derives dot S. Okay, so if this is the set I0, okay, then from the first rule, I0 contains this rule itself. Then if you look at this has the format A, let me use a different color, A derives alpha dot B beta. So here A is S dash, alpha is epsilon, nothing, dot is there, B is your S, and beta is your epsilon. Okay, then what we have to do, we have to include, if there is a production, we have to see if there is a production from of this type, B derives gamma. So we already have items like this. We have a production like this, S derives dash dash. Okay, this and this, two productions we have. So we have to add in the closure of this the items with a dot in front of, in the beginning, all these productions with a dot here and a dot here. So to this we will add, to this set we will add S derives dot S derives dot epsilon means dot. So what you get here is the closure of this set of item. So this is what is a closure. Let us look at now what is the Goto process. So here you can see a Goto is basically, it's a function of two values. One is, the first argument is a set of items. It's a set of items. I is a set of items. And X here is a grammar symbol. It can be either a terminal or a non-terminal. So go to I on a grammar symbol. So what it means is that it's a closure of all items of this format, such that this item is in I. If you look at this item, you'll see A derives alpha dot x beta. So go to I on x, it means that alpha, you have already read up to alpha, you have for the I production, you have already read up to alpha, and then next item to be read is x. Okay, so after reading x, where will you go? You will go here. You will be here, alpha x dot beta. Okay, so the go-to of I, so if I contains a production like this, then for every grammar symbol x, you have to compute the closure of this set. A derives alpha x dot beta. So basically it means that, okay, you have already seen up to this point, up to alpha you have already seen. Now next when you see x, then where are you going to go? So that is your go-to. So after looking at x, you will go to the closure of this item, alpha x dot beta. Okay, so that is the go-to. So let us see this with an example. So with our augmented grammar, this one, let us start with the first set I want to construct the closure of is from the augmented start symbol with a dot in the beginning. Okay, so s dash derives dot s. So now I have to construct the closure of this set. Closure of this set. So closure of I0. Closure of I0 would include itself. This is according to rule number 1. And according to rule number 2, here it should include all items starting with S. That means all items of S with a dot in the beginning. So here this is the production of S. So with a dot in the beginning and dot in the beginning. So epsilon, there's nothing, so this much. So I have I0. This is the closure of I0. Now I have to go on constructing the sets. So let's just see. So from here, let me take this particular production or this particular item. So my next item is, let me call it I1. Okay, I start with S dash. Now what do? That means if I take this, then I have to, that means I have already seen S. So S dash on S, what will it go to? It will go to S dot. So it has seen S. Here it had not seen S, but now it has seen S. So it will go to this. So this is what? This is nothing but your go to I0 on S. So go to, you'll realize that you have to construct go to only on the symbols where the dot is. Like here, dot is before S, so you have to construct go to S. Here for the second production, the dot is before parenthesis, so you have to find out dot parenthesis. For the third production item, there is nothing, so it will remain as it is. So that means now we have to construct a set go to I0S, means after I0 on getting S, it will move to this. It will go to this item, S dash derives S dot. So after this, now we have to construct closure of I0. I1. So closure of I1 will contain itself. Now rule 2 does not appear here anymore because dot is the last one. There is no other variables after it. So I have this. So this is our closure of I1. Okay. Now again from the first set I0. I0 now on S we have seen where it will go to. It will go to I1. So let me just write it. I0 on S goes to I1. But I0, from I0 I can also get a opening parenthesis. So I0 on opening parenthesis, where will it go to? So let me call this set I2. So I have S derives parenthesis. After seeing parenthesis, it will be here. Okay. So now we have to compute closure of. So that means now here I0 on seeing parenthesis. So that means go to I0 on opening parenthesis. It will go to I2. So I2, I have to construct the closure of I2. Closure of I2, I2 will contain itself. Okay, S derives parenthesis dot this. Then again, from rule number 2, that means the dot is before S. So all productions of S with a dot in the beginning. So dot and S dot. So what is this? This is closure of I2. For the third production here in I0, here there's nothing to move because it is already at the end, so you cannot go to anywhere else. Okay, so I got here I0 on S will go to I1. Then we computed the closure of I1. Okay, then I0 on parenthesis will go to I2. Okay, and we computed the closure of I2. Okay, then no more items left. Closure of I0, no more items in this left. So we are done with I0. Now we will go to the next item, that is the next set. We'll go to I1. In I1 we see that there is only one item, S dash derives S dot. Now if the dot is at the end, then there is nowhere to go because you have reached the end of the string. So this, you can say this is a final item. We'll keep it as it is. We are not going to use any Goto here. But you can see I2, okay, I2, I can have two Gotos here. I can have S on capital S, dot is here, the dot is here. So I can go to S or I can go to parenthesis. Let us see what happens now. So here I can have go to I2 on capital S, and from here I can have go to I2 on parenthesis. Okay, let us see capital S, what happens. I3, let us call it I3. So on encountering capital S, it goes here. Okay, so what is the closure of I3? Closure of I3 is itself the same. Okay, and since after the dot there is no variable, it's a terminal symbol, so we stop here. So this is our I3. This is our I3. All right, so go to I2 on S is it goes to I3. What about go to I2 on parenthesis? That is the second item. So here we see S parenthesis dot S, let's call it I4. Okay, now compute the closure of I4. I4, it will contain this particular item, then all production starting with S with a dot in the beginning. So this and this. Now if you look at I4, you will find that I4 and I2, that is this one, I2, they are just the same. They are the same. So what we will do, we will not construct a new set. So we will say I2 on parenthesis goes to I2 itself. Because I4 that we constructed, this is exactly same as the set I2. So I2 on parenthesis, open parenthesis, goes to I2 itself. So it's a recursion, goes to itself. So this is your I2 symbol. Then the third production is item of I2 is the same, it is dot, so it is ending there itself, so it cannot move any forward. So we have done I1, we have looked at I0, then I1 is ending, then I2 here on S, I2 goes to I3, and on parenthesis it goes to, opening parenthesis, it goes to itself. So we have seen I0, we have seen I1, okay, and we have seen I2. Now I3, let us see now. So I will just remove this, I4 is no longer there. Okay, so no I4 here. So I'll take the production in I3. I3, where we can move the dot, we can move the dot here. So I'll get S dot parentheses S dot S. So let us call this set as I4. So closure of I4 would be itself. Then since after this there is a variable, so all productions of S starting with a dot. Okay, now is this same, is I4 same as any of the sets that we have created? No, because this first item is different. So this is our item set I4. Okay, so let us see the Goto now. So Goto of this, Goto I3 on parenthesis, where will it go to? It will go to I4. It will go to I4. So I have I0, I1, I2, I3 and I4. And then I have, now let us look at the productions of I4 or the items of I4. This one here. So here what I can see a dot. I can see a dot. So here I can have go to I4 on S. From here I can have go to I4 on opening parenthesis, and here I can have nothing. For the last one I don't have anything. So let us construct for the first one. So I4 on capital S. So I4 on capital S, that is S derives here. So let's call this I5. So closure of I5 will contain itself, plus the dot is at the end, so no more new items. So this is the closure of I5. So I4 on S goes to, Goto of this is equal to I5. Let's look at this I4. So I4 on parenthesis means the dot will come here. So I have S derives this. So let me call it I6. So if I compute now, so all productions starting with S, so dot S, okay. Again, isn't this same as our I2? It's same as I2. So same as I2. So we will not use this anymore. So we will write here go to this, on this will go to I2. So I have this, all the sets done now. I4, this is the dot. Then we have here, this is also final. So no more items are remaining. So let us write it down properly. What is I0, I1, I2 and I3? So I0, I had S dash derives. So S dash derives dot S. Then the closure of this was your dot S here. Then so this was our I0. Then we got I1. I1 was this one. Closure of I1 was S dash derives S dash derives S dot. So this was I1. Then we had I2. I2 was so here I have I2, the set I2. Next, let us write the let's write the next all the other items. So these are the item sets, as you can see, and we can see that from here you can have the Goto, you can draw the Goto on S. I0 goes to I1. On parenthesis, I0 goes to I2. Okay, then I1 here is a final item. Then from I2 we'll see on S, I2 on S goes to I3 and I2 on parenthesis goes to itself. Okay, then I3 on parenthesis goes to I4. Okay, and I4 on S goes to I4 on S goes to I2, and this is I4 on S goes to I6, and I4 on parenthesis goes to I2. So what you can see here is something which looks like a finite state machine. So it's like a DFA where you have certain transitions from different item sets. So this is this particular set which we constructed. Each of this is a closure. Each of this set is a closure. And each of these transitions is represented by your Goto function. So by computing the closure and the Goto functions for the items in our item sets, we will get this particular DFA. And with this we can construct, we are now ready to construct the parsing tables. So the construction of the parsing tables we'll see in a different video.